Okay, ladies and gentlemen, welcome to the first of the 11 videos that will cover the solution manual to your Chapter 1 review for pre-calculus. This particular video will cover Station 1. There will be a video for each of the 11 stations of your review packet. Here we go. We use the functions above to evaluate the following, and it starts with f of 6. So again, that means we are going to plug 6 into f, which means we're doing the square root of 6 squared minus 3 times 6. That would be the square root of 36 minus 18, which is the square root of 18. Now I would expect you to reduce that down to 3 root 2. All right, next up we've got g of negative 4. Once again, that means we're plugging negative 4 into g. Excuse me. That would be negative 2 times the absolute value of negative 4 minus 3 plus 1. So that would be negative 2 times the absolute value of negative 7 plus 1, which would be negative 2 times 7, because the absolute value of negative 7 is 7. That would be negative 14 plus 1. So g of negative 4 is negative 13. Next up, we have h of negative 1. If we're doing h of negative 1, that is going to be the middle piece because x equals negative 1 is in that domain. Okay? So that would be the middle piece. So we're plugging that negative 1 into 5 minus x squared. That would be 5 minus 1. So h of negative 1 would be 4. And finally on this page, h of positive 5, that is in piece 3, or the third piece, the bottom piece. Because again, this says x equals 5, which means we're looking at this range. Okay, so we're doing the bottom piece. So h of 5 is 7. No more work needed. Okay, on the next four, on E, it says f of 0. So again, we're just plugging 0 in to f of x, which would be the square root of 0 squared minus 3 times 0. That would be the square root of 0, or 0. So f of 0 is 0. For g of 0, that would be negative 2 times the absolute value 0 minus 3 plus 1. So again, we start off on the inside there doing the absolute value of negative 3 plus 1. That is negative 2 times 3 plus 1. That is negative 6 plus 1, meaning that g of 0 is negative 5. h of 0, that is the middle piece, because x equals 0 is part of the middle range. So we would say h of 0 is 5 minus 0 squared. So h of 0 is 5 minus 0, or 5. h of 2, well, if x equals 2, that is not in the domain, which means that h of 2 is undefined. Okay, on to I. Now we're into these ones here where a couple of them in a row are abstract, meaning we're plugging in a variable as well. So all we can really do for f of 2a is plug 2a in, so 2a squared minus 3 times 2a. And then we can't do a whole lot with that. All we can do is simplify. For instance, 2a squared, 2a quantity squared is 4a squared, and negative 3 times 2a is negative 6a. That's all we can do. That is the answer. We covered j in class, but we'll cover it again real quick just to be sure. G of 3k minus 1 is negative 2 times the absolute value of 3k minus 1 minus 3 plus 1. We can't do much with that. All we can do there is simplify the -1 and the -3 into a -4. There's nothing else that can be simplified. That is the answer, is 3k, -2 times the absolute value of 3k minus 4 plus 1. Okay, for part K, it says that we're going to evaluate h when x equals -3. So that is the top piece, because x equals -3 is less than -2, so that would be the top piece, meaning that h of -3 gets plugged into that top piece, 2 times -3 minus 1. So h of -3 is -6 minus 1, or -7. And the final problem of this part is g of 6. So again, we're going to plug that into g. G of 6 would be -2 times the absolute value of 6 minus 3 plus 1. And then we simplify that as much as humanly possible. So that's the absolute value of 3 is the first step. 6 minus 3 is 3. The absolute value of 3 is 3, so that doesn't change anything. Then we multiply, which gives us -6 plus 1. So g of 6 is -5. That does it for station 1. Our next video will cover station 2. Thank you very much for your time and attention.